Okay, so we're closing in on getting towards the end of our building blocks unit. We will talk a little bit today about linear pairs and vertical angles. So the first thing we'll start discussing are linear pairs. So the first thing that's important to realize about a linear pair is that they are a pair of adjacent angles. This definition that I have up here says that it's formed when two lines are intersecting. However, it doesn't necessarily have to be two intersecting lines. In this situation, I have a one line AC that's being intersected by a ray, which I can't officially name because I don't have another point on it. But I can clearly see that these two angles, angles 1 and 2, are definitely adjacent. Okay, I do have that they share a vertex and they share a side. So angles 1 and 2 would be considered adjacent angles. Also, they lie along a common line. So because they lie along a common line, that's kind of the other aspect of it being a linear pair. They would be supplementary angles. They would total 180. Okay, so any line forms 180 degrees. So it's worth noting that the measure of angle 1 plus the measure of angle 2 would equal 180 degrees. Okay, it doesn't necessarily have to just be a line and a ray. It could be the same situation as kind of more how that definition is written, where you have two intersecting lines. So for easy reference, I'll write down the numbers in the lines. And I have quite a few different linear pairs happening here. Let's zero in on angle 2 and angle 3. So because angle 2 and angle 3 share a common side, that red side right there, that's considered its adjacent side. They lie along the same common line or formed by one by a common line. They are considered supplementary. So angle 2 and angle 3 are supplementary angles because they are also adjacent. We would call them a linear pair. Now technically it doesn't even have to look like this. I can have a linear pair that would appear inside of a triangle. So I could give you this triangle here. I could divide that triangle with this line right here, give you angle 1 and angle 2. Now I could tell you that they're adjacent because they share a vertex, they share a side, they lie along the same line at the bottom, making them supplementary equal to 180 degrees. Okay, so let's go through a few examples. There's a lot of math or calculations and algebra involved here. So the first thing is I'm going to highlight why they are a linear pair. So two adjacent angles along the same line. They are supplementary. So I know that B plus 35 would equal 180. So of course B would equal 145 degrees. Okay, a bit more involved here, but not significant. So again, I do have this time two intersecting lines, but to again highlight the fact that they are adjacent. They lie along the same bottom line here, so then these two would be considered supplementary. So adjacent supplementary angles are a linear pair. So I know because they're supplementary, I can add them together and set them equal to 180. So of course, 3x plus 33 is equal to 180. And so we'll get down to x equaling 49. Okay. Again, another pair of adjacent angles lying along the same lines, making them supplementary, a linear pair and supplementary. So to solve for my variable, I'm going to do 5x minus 18 plus 4x plus 45 equals 180. I'll get down to 9x plus 27 is 180 degrees. So we got 9x equaling 153 to finish up with x equaling 17 here. Okay, I give you 2 to try on your own. Give it your best, and we will chat about it in class. The last thing that we're going to talk about on this video is going to be about vertical angles. So vertical angles, they are often seen when you see vertical angles, but or linear pairs rather, but they are rather kind of the complete opposite if you think about it, because they are not adjacent. They are a pair of angles that are not adjacent. So if you take a look, I have angles for quick reference. I'm going to just number some angles here. It won't let me write that far, so I'm going to call that one 4. So I have 2 pairs of vertical angles here. So my 2 pairs of vertical angles are my 2 pairs of non-adjacent angles. So angle 1 and angle 2 would not be considered adjacent. Angle 3 and angle 4 would not be considered adjacent. So although they do share a vertex, they do not share a side. And because they do not share a side, they're not considered verticals. You do have a bit of less flexibility when it comes to finding vertical angles versus finding linear pairs. Vertical angles would really only be found when you have 2 intersecting lines, because you do need 2 non-adjacent. So that's really only going to happen. Yes, they can be segments. Yes, they can be 1 segment and 1 line, but you do kind of need them to be fully extended, where with a linear pair, you wouldn't need that necessarily. Now, the relationship of a vertical angle or vertical angle pair is that they are congruent. So I know that angle 1 is congruent to angle 2 here. Okay, and the other pair is as well. Angle 4 would be congruent to angle 3, or the other way of looking at it is the measure of angle 1 is equal to the measure of angle 2, and the measure of angle 4 is equal to the measure of angle 3. Now, it's also worth noting that in this situation, you often can use linear pairs to help you find vertical angles as well, and we'll see that in the first example. So here I have 2 intersecting lines. I have quite a few different angles happening. So I have a linear pair with the 65-degree angle and the angle that's labeled X. I know that because those 2 are adjacent. They share that red side. As opposed to 2 angles like, let's say, Z and X, which may have a common vertex down right here, but because they do not share a common side, they are non-adjacent angles, and so X and Y would be considered vertical. Now I know that angle X would be congruent to angle Y, so if I knew one, I would definitely know the other. The problem is I don't know either. However, I could flip and take a look at this angle that measures 65 and this angle measured Y. So I know that those 2 are also non-adjacent angles formed by 2 intersecting lines, and so I know Y has to be congruent with that 65-degree angle, and so I know the measure of angle Y is 65 degrees. Now, taking a look back at my 2 my linear pair here, I know that linear pairs are supplementary, so I would know that the X plus the 165-degree angle would equal 180. And so then I understand that x has to be 115. And now because I already addressed that x and y are vertical and congruent, I know also that angle y is 115. We'll step up the algebra a bit with this example, but it's certainly not any more difficult, okay? So we should note that these are not adjacent. They do not share a side, okay? However, I do know that they do have a common relationship, which is that because they are vertical angles, they are congruent to each other. So I'm going to set them equal to each other. Congruent. So 11y minus 36 is equal to 63, giving us 11y equals 99, and of course, y being 9. Very much similar problem here. Just going to end up with an equation that looks slightly different. Two non-adjacent angles. They do not share a side. They are vertical angles. The measures of these two angles are congruent, and so I know 9y plus 7 is equal to 2y plus 98. So I know that 7y would equal 91, and so y is going to get down to 13 degrees here. Okay, you now have 2 to try on your own. Again, do the best that you can with it, and we will take a look at them together in class.